Hey guys, this is Advanced Math, and today we are doing we're starting a quick mini unit on graphing lines and linear equations and slope and intercept, just to get that back in your minds and refresh something I know that you have learned before. So we are going to fly through this pretty quickly because this is not new information. This is just a review of something that you have already learned. So let's start with this. Evaluate 1/2 x minus 3 for the following values of x. Hopefully by this point you know what that means is that you need to plug and chug or use some substitution. Remember that when you substitute in a value into an equation for a variable, be sure to use parentheses. So when we substitute in 1/2 times 2 minus 3, what we get is 1/2 of 2, which is just 1 minus 3, and 1 minus 3 leads us to negative 2. When we substitute in our negative 2, again using parentheses, 1/2 of negative 2 is negative 1, and negative 1 minus 3, gave the answer away there just a little bit, is negative 4. When we substitute in 1, again use parentheses, minus 3, we get 1/2 of 1 is 1/2. And 1/2 minus 3 is negative 2.5. Which you could write as negative 5/2. You'll also see it as negative 5/2 as we use improper fractions. I don't actually use mixed numbers a whole lot. It's just much more practical to use improper fractions. Let's evaluate negative 2x plus 5 for the following values of x. Do this on your own. Plug those in using substitution, use parentheses, and tell me what you get. Well, negative 2 times 0 plus 5 is just 5. Because negative 2 times 0 is 0. And negative 2 times negative 2 times negative 1/2 plus 5 is actually 6. Negative 2 times negative 1/2 is positive 1, and positive 1 plus 5 is 6. Hopefully you got both of those. Our biblical correlation for this unit comes from Job 38:5, which says, "Who marked off its dimensions? Surely you know. Who stretched out a measuring line across?" We know that this is in a part where God is answering Job after Job has been asking God all of these questions, and he's saying, "Who are you, O man, to question me? Who did all this?" And we see that God makes a mention of marking off the dimensions of heaven and marking off the dimensions of earth. And this just gives us further evidence that our God is a God who created math for us to use. He is the creator of math and measurement, and it is for us to use as part of his creation. Our lesson objective for today is that you, the student, will graph linear equations on the coordinate plane using ordered pairs and determine the x and y intercepts of a linear equation. By recognizing key characteristics of a function, which is an equation that shows us a relationship between x and y, you can quickly determine the shape and location of its graph. Linear functions can be written a couple of different ways. You see here, we have f of x equals 2x plus 7, or y equals 2x plus 7. Y and f of x are the same thing. When we're talking about the coordinate plane, we know that we always graph on the x-axis first, right here. And where we plot our y point depends or is a function of where we plot our x point. So if we're plotting, for example, 3, 1, we would have to go over 3 and up 1. And this y being way over here depended on the x first of all. So x or y always depends on x. Y is a function of x, and that's where we get this function notation. These are called linear functions or linear equations because all the points that would make this equation true or that would satisfy them form a straight line. Linear functions have your x variable raised to the first power. X to the first power is a linear function. I could plug in 3, I could plug in 4, no matter what values I plug in for x, whatever y values I get, if I connect these, they're always going to form a straight line, and that's why they're called linear functions. So let's see if it's true. Let's look at this function, y equals x plus 5, and graph it. So we're going to make a table here. We're going to choose any x values that we want. We're going to plug in to x plus 5, and we'll get our coordinates here. Once we plot these, we'll see if in fact they do form a straight line. So let's go ahead and choose negative 2 and plug that in. And when we do that, we get our y equals 3, so our coordinate is negative 2, 3. What about negative 1? Substitute that in using parentheses, and you get y equals 4, so therefore our coordinate is negative 1, 4. When we plug in 0, we just get 5, so our coordinate is 0, 5. When we plug in 1, we get 6, so our coordinate is 1, 6. And when we plug in 2, we get 7, so our coordinate is 2, 7. So now we have this set of coordinate points, this relation here, and we are going to go ahead and graph those and see if in fact we do get a straight line like we just said we should. All right, so let's take a look at our Cartesian plane here. Cartesian plane, the coordinate grid, the graph, whatever you want to call it. I will always refer to it as the Cartesian plane. Our Cartesian plane, don't forget, has 4 different quadrants. We're going to start up here in the upper right quadrant. That is quadrant 1. This is where we're typically going to graph, where we graph relationships between real world things because both our x and our y are positive. So we would plot all of our positive points here. Over here to the left, my x is negative, but my y is still positive. That's quadrant 2. Down here in the lower corner, we have both x and y are negative. That's quadrant 3. And then quadrant 4, my x is positive, but my y is negative. All right, so let's plot these points here. I've got negative 2, positive 3. So I'm going to go first left 2 on the x-axis and up 3 on the y-axis. Remember, y depends on x. Then I've got negative 1, 4. So that means to the left 1 and up 4. 0, 5 means I don't go right or left. I stay here at 0 and I go up 5. 1, 6 means to the right 1 and up 6. And positive 2, positive 7 is to the right 2 and up 7. If I were to connect those spots or those points, you can see that they do in fact form a straight line, proving that this is a linear function. The standard form of a linear function, a linear equation, is ax plus by equals c, where a, b, and c are real numbers, and x and y are our variables that we could use to represent our data on the xy coordinates, xy plane, Cartesian plane. If a linear equation in standard form contains fractional or decimal coefficients, we want to multiply each term so that a, b, and c become integers. We want to make sure we don't have any decimals or fractional coefficients in there. It's also common for a to be non-negatives. So we may have to divide the whole thing by -1 if we want to make sure our a is not negative. Let's take a look at some examples. We want to convert this to standard form. Don't forget, standard form is ax plus by equals c. All right, and you can tell that that is not what this looks like. So step 1, we're going to first replace our f of x with y. They are the same thing, but in standard form, we want to make sure that we have y, not f of x. Now, if you look at standard form, we need to get our x and our y terms on the same side. And we need our constant, this 2, to be all by itself on the right-hand side. So we will add 5/7. Since this is a -5/7, we will add 5/7 x to both sides. And when we do that, we get 5/7 x plus y equals 2. Now, we're not quite done yet because we do want this to be an integer. We don't want 5/7. And the way that we eliminate a fraction or eliminate a denominator is multiplying by what's ever in the denominator. So if we multiply this whole thing times 7 and distribute the 7, in this first piece here, 7 times 5/7 is just 5. 7 times y is 7y, and 7 times 2 is 14. We now have this in standard form, where our a's, b's, and c's are integers, and our a term is a positive number. It is not negative. We're going to try to graph this one, and we're going to graph by making a chart. We have x plus 3y equals 4. We are first going to solve for y. That doesn't mean y will be a number. It just means we're going to rewrite the equation in terms of y. We want to get y by itself. So in order to do that first, we need to move this x over to the other side, which gives us 3y equals 4 minus x. And then right now the y is being multiplied by 3. In order to undo that multiplication, we've got to divide by 3. When we divide by 3, we need to divide each of those pieces by 3. So we get y equals negative x over 3 plus 4 over 3. We're then going to make a table to find ordered pairs. So we'll make this 3-column table. On the left, we'll choose some x values. And in the middle, we'll plug and chug. And on the right, we'll list our ordered pair. So when we choose a -1, for example, and plug that in, we get that y is equal to 5/3, resulting in this ordered pair. When we plug in 0, we get 4/3, resulting in this ordered pair. When we plug in 1, we get 1, which results in this ordered pair. And when we plug in 4, we get 0, resulting in this ordered pair. We're then going to plot our points and graph that ordered pair. Graph all the ordered pairs. We'll connect it with a straight line to show that this is a linear function. When graphing a linear equation, don't forget first to solve the linear equation for y. Again, that does not mean that you're going to have a number like y equals 3. You were just rewriting the equation so that it's in terms of y. Y equals the rest of the equation. We'll then make a table of at least 3 ordered pairs using convenient values for x. I like to do 5, and I recommend usually that you try at least a 0 and a couple of negative and a couple of positives. We'll then graph the ordered pairs on our Cartesian plane. That's the 4-quadrant coordinate grid graph that you're used to using, called the Cartesian plane, and connect the points with a straight line to show that any x values on that line will plug into the solution and give us that corresponding y value. Now, most of the time your points are in quadrants 1, 2, 3, or 4. Like you saw when we listed those quadrants, I'll do it with regular numbers here. However, occasionally you'll have a point that's right on the line. In these cases, the points are not in the quadrant at all. When they're on the line, they're called an intercept. The y-intercept is the point where the graph is on the y-line or crosses the y-axis. The x-intercept is a point that lies on the x-line or crosses the x-axis. So right here where I have my mouse, that is an x-intercept, and this is a y-intercept. Those points are not in quadrants, they are right on the line. A line's intercepts can be found from the equation without even graphing, using a little bit of logic. If we go back here, we know that when there is an x-intercept right on the line, that the y value is 0, because the dot isn't above or below the x-axis, so our y value must be 0. So we could plug in a 0 every time we see a y. For the y-intercept, like here, we know that the x is 0 because we didn't go to the left or to the right from the origin, we just went straight up. So our x is 0. So we can plug in a 0 for the x to solve for y. And that's what this statement says here. The the y-intercept always has a 0 for its x coordinate. The x-intercept always has 0 for its y coordinate. Let's take a look at an example. 2x plus y equals 6. To find the x-intercept, we would substitute 0 in for y, and just find the places where it's on the x-line. When we do that, we get 2x plus 0 equals 6. Divide both sides by 2 to get x equals 3. So our x-intercept is 3. So, boom, boom, boom. There's our x-intercept, right at x equals 3. To find our y-intercept, we would plug in 0 for x. We only want to know y. So 2 times 0 is 0. That leaves us with y equals 6. So our y-intercept would be 1, 2, 3, 4, 5, 6, right up here. Not to the left and not to the right, just right on the line at 6. We would then plot each intercept, 3, 0 and 0, 6. We could then graph the line just by connecting those two intercepts. We can check by using a third point to make sure that our line is drawn accurately. Let's see what that would look like. There we go. So we have 3, 0, we have 0, 6, and here's a point that falls on the line that works with the equation. we are going to end the first video here. If you have any questions, ask me next class.